Hey everybody, in this video we are going to complete the identity on your screen. So I'm going to go about this in what some people might think not the most practical way for whatever reason. But the reality of it is that I'm trying to show you a technique that is going to work all of the time, even though when it comes to a case-by-case basis, you may choose to do more customized, specific things based on what's in front of you. So I'm going to show you my method, and this is to be applied more broadly. All right. So what do we have? I have cosecant times cotangent over secant. First thing I might like to do is get rid of my denominators. I don't have any sums or differences, so I can just move things from bottom to top using reciprocal identities. What do I mean by that? Well, I'm going to leave whatever I have in the numerator. So that's going to be cosecant theta and cotangent theta. So for right now, I'm just leaving them alone. But the secant theta on bottom, okay, when I bring that up, what I like to say to myself is secant on bottom is the same as cosine on top and vice versa. All right. I'm leaving room in case I want to talk about a different way to do it over there. That's all. This might be the only way to do it. I got to think about it. So from here, once I have everything across in a numerator, if you will, because my denominator is 1, now I'm going to go into what I like to call panic mode, which is rewriting everything using only sines and cosines. So cosecant will become 1 over, I don't know why I'm using parentheses all of a sudden, 1 over sine. They're not necessary. It was so weird that I did that. Cotangent can be written as cosine. And if you don't know these rules, that's also where you're running into trouble, okay? Even if you're given rules like this on a piece of paper, it can only help you so much because it's hard to develop a plan of what to do next if you have to keep looking. It's like, driving without the directions and you're like on the highway and the next turn's coming and you're trying to read up on what the next turn is. It's not like, even sometimes when it's prompted to you, if you're not paying attention to what's coming next and you don't know the route, it's a little bumpy sometimes and you could miss a turn. All right. So doing this is sort of the same idea. Now cosine theta, I'll talk about this again in the next example, but cosine of theta can stay. You don't have to change everything. Like some things can stay. It's already written. I don't think that's supposed to be cosine. No, guys, why don't you stop me? It's supposed to be cotangent. Since it's supposed to be cotangent, right? Oh no, I was right. It is cosine. It came from the bottom. Hello. I thought I was looking at the cotangent right next to it. I was going to say, why didn't you guys tell me? There we go. Like it never happened. We all make mistakes. It's okay. All right. So the cosine can stay as it is. So that was the secant from the bottom. So I'm just going to draw little arrows so I remember where that came from. And then these two came from the top right there. Okay. So maybe I'll, for my own brain, kind of look at that. Maybe that'll help me. All right. Next step. If I have things that match on top and bottom, this is where I can cross things out as long as everything is multiplication and division, no addition and subtraction. So I can't. I have two cosines on top being multiplied together. I have sine and sine on bottom being multiplied together. So I'm going to do what it wants me to do. That's cosine squared theta over sine squared theta. Our end goal is whenever possible to try to write these as a single trigonometric function, single trigonometric expression with a single function in it. So I have 2 right now. And additionally, if I have to have 2 left, I don't really want any in the denominator. Take a good look at it, zoom out, step back. Cosine over sine is cotangent. So this is really cotangent squared theta, and we're done. Now, what was I saying in the beginning? Is there a more practical way? Kind of. So I could leave that cotangent the way it is. And then I could kind of bust out a little associative property. That's where we associate different things together. Right now, my numerator, those two, cosecant and cotangent, those are being associated together, and the secant's kind of like on the side, hit the road, we'll deal with you later. I want to look at it associating cosecant and secant together and kind of like let cotangent be on the side. Multiplication does not have to come before division. PEMDAS is sort of like a lie because multiplication and division really are the same thing. So they are interchangeable, as are addition and subtraction. So if you know the bonus quotient identity, not only does cotangent equal c over s, cosine over sine, it also equals c over s, cosecant over secant. So that right there is another cotangent. So that brings me cotangent times cotangent, which again, we finish with cotangent squared theta. So if you need to listen again, watch it again, please go ahead and do that. If you want to see another example, please click through for the next example. If you feel smart, thumbs up. If you hated everything about this and you don't get it, thumbs down. Did it a different way? Give me feedback in the comment section. I'd love to know how you did it. Always looking for more clever ways of doing things, or just sometimes an interesting way. Maybe it's not as short, maybe there's an extra step, but it could also be beneficial for a different problem in the future to use that technique. So always good to talk about. All right, click through for the next. Hope you're feeling smarter, and adios.